Welcome to ETE MCQs. Let us solve a NPTEL assignment problem. Consider the Laplace transform x of s is equal to s minus 1 divided by s squared plus 3s plus 2. So we are given with a Laplace transformed sequence which is given as x of s is equal to s minus 1 divided by s squared plus 3s plus 2. So this is your Laplace transformed sequence. Again, an ROC condition is mentioned, ROC minus 2 greater than real part of s and it is less than minus 1. So you are supposed to find the corresponding inverse Laplace transform which satisfies this condition. That is ROC. It should satisfy this ROC. Okay, let us get back to this ROC condition later. Let us do the initial partial fraction expansion and try to split this rational function into two single pole functions. Since the order of the system is 2, you should get two single pole functions. Okay, and the single pole functions will basically depend on the formula of basic Laplace transform, which is given as. So let us write the Laplace transform formulas that will be required for this problem. That is Laplace transform of e power minus at into u of t is equal to 1 divided by s plus a with ROC. We will write ROC as real part of s and the pole. Pole is minus a in this case. Since this Laplace transformation corresponds to a right-sided sequence, just put a greater than sign here. That is real part of s is greater than minus a. The other Laplace transform, write the Laplace transform of a left-sided sequence. Laplace transform of minus e power minus at into u of minus t is equal to 1 by s plus a. So both the time domain sequence is having the same Laplace transformation, but they are differentiated based on the region of convergence. If the region of convergence is not specified, then we won't be able to find the respective time domain sequence. So that is the unique importance of region of convergence. The transformation of more than one time domain signal will be the same, but they can be differentiated based on the region of convergence. So here you will have again, the pole is minus a, real part of s and minus a. Since this transformation corresponds to a left-sided sequence, just put a less than sign. Whereas in the previous case, since the transformation corresponds to a right-sided sequence, put a greater than sign. That's it. Without knowing these two transformations, we won't be able to produce the inverse Laplace transformation or get the inverse Laplace transformation which will satisfy this RO. Now rewriting the rational function in terms of factors, we can say that x of n, s can be rewritten as s minus 1 divided by s plus 1 into s plus 2. That's it. So the denominator is rewritten in terms of factors. Now let us apply the method of partial fraction. Now based on method of partial fraction, we can rewrite it as s minus 1 divided by s plus 1 into s plus 2. This can be rewritten as a divided, based on method of partial fraction, can be rewritten as a by s plus 1 plus b by s plus 2. Now, which can be further rewritten as s minus 1 divided by s plus 1 into s plus 2 is equal to a into s plus 2 plus b into s plus 1, the whole divided by s plus 1 into s plus 2. So, upon cancellation of these two terms in the denominator, we will have s minus 1 is equal to a into s plus 2 plus b into s plus 1. Now, in order to find a, let us substitute s is equal to minus 1. So, when s is equal to minus 1, what happens? I'll get, I substitute, let me take it as equation number 1. In 1 I am substituting s is equal to minus 1. When I substitute s is equal to minus 1 in 1, I get minus 1 is equal to a into minus 1 plus 2 plus b into minus 1 plus 1. So this becomes 0. So you have minus 2 is equal to a, which means that a is equal to minus 2. A is minus 2. Similarly, in order to find b, let us substitute s is equal to minus 2. When s is equal to minus 2, we can find b. So when s is equal to minus 2, what happens? You get minus 2 minus 1 is equal to a into minus 2 plus 2 plus b into minus 2 plus 1. Finally, we get, which means that minus and minus upon cancellation, b is equal to 3. So we have obtained or determined the arbitrary constants. A is equal to minus 2 and b is equal to 3. Substituting a and b in x of s. What do we get? We get x of s is equal to a divided by s plus 1. A is minus 2, so minus 2 divided by s plus 1, and b is 3 plus b is nothing but 3, so you will have 3 divided by s plus 2. Now what you can notice is, based on the region of convergence, the single pole function that corresponds to pole minus 2 should be a right-sided sequence. So this should be this is the single pole function whose pole is minus 2. So this should be a right-sided sequence. Likewise, since you have a real part of s less than minus 1 sign, the pole which corresponds to this minus 1 is this 1 by s plus 1. Ignore the constant. It is s plus 1. The pole will be minus 1. So this should correspond to a left-sided sequence. So this should be a right-sided sequence and this should be a left-sided sequence. Only then the region of convergence condition will be satisfied. So the first term should correspond to a left-sided sequence. I am just mentioning it for our convenience. While the second term corresponds to a right-sided sequence. Only then the ROC will get satisfied. Now taking inverse Laplace transform, we get x of s on taking inverse Laplace transform becomes x of t, which is equal to minus 2 is a constant. So you put a minus 2 is basically a constant. And you are supposed to take the Laplace inverse of 1 by s plus 1. And then next it is plus 3 into Laplace inverse of 1 by s plus 2. As it is said already, this should correspond to a left-sided sequence. If it is a left-sided sequence, we have for 1 by s plus a, we have minus e power minus at u of minus t as the inverse Laplace transform of this term. The inverse Laplace transform of 1 by s plus a is e power minus at into u of minus t. So let me just substitute it here. After I take the inverse, I will have minus 2 the whole into inverse Laplace of 1 by s plus 1 is minus e power minus t into u of minus t. Okay, similarly plus, now this one corresponds to a left-sided sequence, plus 3 times Laplace inverse of 1 by s plus 2, and this should correspond to a right-sided sequence. So the inverse Laplace transform of from this first formula, you can say that the inverse Laplace is e power minus 2t u of t, the whole into e power minus 2t into u of t. Now finally you get minus 2 into minus becomes plus, so 2 times e power minus t into u of minus t plus 3 times e power minus 2t into u of t. So let us focus on the first ROC of the left-sided sequence. This left-sided sequence and its ROC. And it is very clear that this problem has got two poles, minus 1 and minus 2. Let the first pole minus 1 be here and minus 2 be here. Okay, this is sigma and this is j. Now for the left-sided sequence, it is very clear that the ROC is on the left-hand side of the pole minus 1. So you will be having the region of convergence will be on the left-hand side of minus 1. This will be the region. Since ROC2 is a right-sided sequence, that it be sigma j omega pole at minus 1 and minus 2. Since the second term is a right-sided sequence, you can notice that it is a right-sided sequence. You will have the ROC to be on the right-hand side of the pole minus 2. It is on the right-hand side of the pole minus 2. Right-hand side of pole minus 2. It extends up to infinity. The ROC extends up to infinity. Now the overall ROC is nothing but the intersection of ROC1 and ROC2. The overall ROC is given as sigma j omega pole at -1 and -2. No pole at -3. Now, if you notice, the intersection between these two is nothing but the region between -1 and -2. This is the common ROC. You just notice this part is your common ROC between -2 and -1. There is a strong region of overlap. It is a patch between -1 and -2. So the given ROC's graphical representation is finally mentioned for your understanding. So this one's graphical representation is this. It's a patch between -1 and -2. Now the correct option for this problem is option A is correct. Thank you.